Hey everybody, welcome to our first day of quarantine e-learning. So I just want to get right into it. Hopefully you watched on the e-learning website or the e-learning page, just the expectations, the update that that we're going through at least till, end of April. What we're going to be doing today is focusing on 1 and 2 step stoichiometry. So if you feel like you are pretty solid on the basics of Stoich, basically the things that we did right before we had a long break, then you are fine. You can move on to 3 step. But in case, it's been a while since we've done this. So I do suggest probably looking at this quick review for a few minutes, 10 minutes, whatever. So on the e-learning page, again, hopefully we're right here, April 2nd, e-learning day number 1, your B day. So there we go. We're going to head down to this review of 1 and 2 step Stoich. Now, again, this is totally optional, just a review. As previously stated, you can print things off. You can use a piece of paper. If you want, you can even type on the actual document. That's fine. I'm going to quickly run through how you could how you can set up some conversions on Google Docs. It requires a lot of clicking, but if you don't want to use, paper, you can do this. That's perfectly fine. But we're going to look at this. So on this, and again, on for videos, obviously pause as long as you need to. You don't have to, don't say I go way too fast, because you can just pause and rewind. So that's the beauty of YouTube. There you go. Beauty of videos. So we're going to look at 1 and 2 step Stoich review. Again, 1 step Stoich is just moles to moles. Nothing crazy. That's converting, again, from graham crackers to chocolate pieces in your s'mores equation. You're just changing up recipes. Okay, nothing too crazy there. But I just want to show a quick review of that. And again, if you wish, you can use your roadmap. And again, it's got all the basics on there. It's got what 1 mole equals. This is the one that I made from like a few weeks ago. You can find this on the other e-learning page. So use that if you wish. I'm going to use this for the 3 step Stoich that we're going to do in the next video. Here we go. So for 1 step Stoich, again, all we're doing is we need a balanced equation. So for this first example, the equation's already balanced, which is nice. We're looking at how many moles of potassium chlorate are needed to produce 15 moles of oxygen, which is right there. So basically, for this reaction, if I'm focusing on potassium chlorate and oxygen, I'm just going to get rid of that guy because I don't need it. It doesn't matter. It's just there just to be there. So what I want to do is show the work for how I can get from moles of oxygen to moles of KClO3. So what I want to do, I'm going to use blue because I feel like it. I'm going to write down our given measurement, or given quantity, which is 15 moles of O2. I'm going to set up a conversion. On the Google Docs, if you want, you can go to Insert up here, and you can insert equation, and this little guy pops up, this little toolbar with equations. You can click right here, this Math Operations tab, and if you click on the A over B, it actually sets up a fraction, and you can use that for your conversion if you want. It makes things look nice, but again, paper and pencil is obviously fine. So if I started with moles of oxygen, for my 1 step, I'm going from moles to moles. So right away on the bottom, I need to have 3 moles of, oh boy, what'd I do? 3 moles of oxygen. Because that's my starting point. I started with moles of oxygen. I need to cancel out with moles of oxygen on the bottom. And again, the 3 comes from there. All right, nothing's changed from before we had our break. And if I'm canceling out moles of oxygen, I'm trying to get to moles of potassium chlorate, which is right up there. And according to this recipe or reaction, every time you make 3 moles of this, you use 2 moles of that. That's our conversion. That's our equality, you could say. Here we go. So I'm going to do 2 moles of KClO3. Don't worry about getting those subscripts down there. I know how to do it. It's weird. And there we go. You should get your answer on the bottom. Answers are going to be given, all the math answers. that answer should be 10. But again, the best way to do this would be 10 moles of KClO. It gives me a unit, and it gives me a substance. Because again, the moles of O2 are going to cancel out. We can see that down here. You're left with moles of KClO3. That's what you want. Woo-hoo. Cool. So that's one step. Again, at any time, just email me if you have questions on some things. If I'm going too fast, just re-watch this part. For two-step, I'm going to head down to number 3 here. I already balanced the equation. Okay, so 2HGO, then 2HGs over here. So note for this, we're still trying to get to moles of this mercury oxide compound, but we're starting with 125 grams of oxygen. So we're starting with grams of one thing, and we're trying to get to moles of something else. So this is going to be a two-step problem. There's moles in one of the substances, and there's a different unit for the other one. Note up here for one step, it was moles to moles. The two-step, it's going to be moles to something, or something to moles. So in our case, we start with grams, trying to get to moles. So what I am going, here we go. So what I'm going to do is set up a conversion. I'm going to start with my given, 125 grams of O2. I'm going to set up a conversion. I have grams at the start, okay? And so if I use my little roadmap, I'm going to show you how you can use this thing. If you start with grams, note I'm up here. You have to go from, there's only one thing to do. You can't do anything else. That's why I use my little road here. The only way you can get down to moles is by using the molar mass. So start with grams and go this way to moles of our substance. And up here, 1 mole is equal to the molar mass. So if you printed yours out or have yours on your Chromebook, please use it. I do suggest using it. So molar mass is 1 mole. That is our conversion factor. Here we go. So 1 mole of O2 is the molar mass, which is 32 grams. Again, that's found on the P table. So molar mass on your P table, okay? I'm not done yet, all right? Because I need to find moles of HGO. I'm in moles of O2. So if you don't show your substances or your units, then you might think you're done, but you're not. Again, I always relate it to getting off the train or getting off, basically a connecting flight if you're flying, whenever we can fly again. Anyway, you need to figure out where your exit is. If you're even driving, where's your exit? Well, I don't know. You're driving blind. You're not going to know where your exit is. You got to keep your eyes open. Look for your exits. In our case, our exit is moles of HGO. But right now we're in moles of oxygen. Oh, but if we look up here, when we had moles of oxygen up here, we just did the ratio. We just did this heart of stoichiometry part, the part you need in all Stoich conversions. That's what I'm going to do. So this should ring a bell. I had a moles of O2 on the top here, so I need to cancel it out. I'm going to put 1 mole of O2 on the bottom. The reason it's 1 is because up here, look, there's 1. Every 1 mole of oxygen, oops, I use 2 moles of, oh boy, HGO. Because look, 2 right there. So grams of oxygen cancel out with the grams of oxygen down there. 1 mole of oxygen up here because that was equal to the molar mass. And then in 1 mole of oxygen, I use 2 moles of that. And there we go. Moles of HGO. We should be good. Everything cancels out. Everything looks pretty good. Do my math, 125 divided by 32 times 2. I should get the 7.8 answer, 7.81 answer down there. So 7.81 moles of HGO. There we go. It's a quick review of 1 and 2 step. I'm going to move on to 3 step in another video. So check that out. Thank you.